oxygen available if... Okay, so now to finish up our understanding of cellular respiration from the perspective of the 4 steps and why we're getting so much ATP over here versus what we got over here, let's talk a little bit about the numbers again. Now again, our 4 steps, glycolysis, occurs outside of the mitochondria in the cytoplasm, gives us 2 ATP, but we break glucose down into our 2 3-carbon products called pyruvate or pyruvic acid. If there's enough oxygen available, then the pyruvate will go into the mitochondria. If there's not enough oxygen available for whatever activity we're doing, then the pyruvate turns into lactic acid, and we only get 2 ATP from 1 glucose molecule. But if we have the aerobic ability to continue whatever we're doing at cellular level, then the pyruvate moves through the 2 membranes of the mitochondria, and we pull some carbon dioxide and some hydrogens out of it, and we turn pyruvate into acetyl. Now, in this process of forming pyruvate, we also pulled some hydrogens out of it. And of course, we know what we're building to is, what are we going to do with all these hydrogens? And we just saw in the last information that we took them to the electron transport chain so we could break the hydrogens into electrons and protons and, go through the oxidative phosphorylation process. Now, so a couple things I want to say before that. Notice that I'm going to get NADH from the first step. I'm going to get NADH from the second step. I'm going to get even more NADH from the third step, quite a bit more NADH, and I'm going to get FADH2 only from the third step. Notice I get NADH from the first 3, but I only get FADH2 from the citric acid cycle, the third step, also called the Krebs cycle. Now, the next thing I want you to notice is we talked about the number of pumps that we saw being activated. So the number of pumps, we were either activating 3 pumps or 2 pumps. Now, look at our numbers here for a second, because if I have NADH and I end up with 6 ATPs, then 2 times what gave me 6? Well, 2 times 3, and how I can remember that is this meant 2 NADHs went through 3 pumps to give me 6 ATP. Now, notice, 6 NADHs then had to go to how many pumps to give me 18? Well, 6 times 3 is 18, so these 6 NADHs that came from this step went through they activated 3 of our pumps, went through the oxidative phosphorylation, gave us 18 ATP. Well, FADH2 never went through the first pump. It only went through the last 2. So notice 2 times 2 pumps give us 4 ATP. All right, now, so we know the NADH energized 3 pumps here, 3 pumps here. FADH2 only energized 2 pumps. What about this first one? How come we have 4 or 6? Well, what we know about that is either if 2 NADH operate 3 pumps, we know we get 6 ATP. But if 2 NADH only operate 2 pumps, we know we only get 4 ATP. 2 times 2 is 4, 2 times 3 is 6. So the difference in the NADH here versus the NADH here and here is that these 2 came from inside the mitochondria. This came from outside the mitochondria into the mitochondria. So one of the theories is that there may be a delay when this comes from outside the mitochondria to where it may be able to start at the first pump, or something may already be preoccupying the first pump, so it may have to be delayed and start at the second pump. Either way, we know we have a variation there. So again, if we get 4, we know it hit 2 pumps or energized 2 pumps. If we get 6, we know that the electron only energized or got 3 pumps. So that when we add these up, then here obviously is our major payload of getting ATP. So things that go through aerobic respiration where we're using oxygen to convert to ATP, it's going to give us a lot more ATP than if we do it only anaerobically, where all we get is basically our glycolysis of glucose to get 2 ATP. So again, when we're able to get enough oxygen in, we get much more ATP. And of course, we add the ATP from here to what we got before we got to the electron transport chain. So then we end up with a total of, the 32 or 34 added to the 4 from these 2 steps gives us a total of 36 to 38 ATP. Now, I want you to watch a couple of the other videos dealing with this, but I think if you watch all these, you will be able to understand the questions that you'll need to know for your next test.